All right, my friend. So another day, another great day for math. All right, so we're going to keep moving our conversation on with discussions about tables of values, and we're going to look at another function today. So we're going to add our second function, which is absolute value functions. And you're going to see that there's some commonalities with linear function, but there's going to be a couple of small things that are going to be important things that are going to separate it from being linear. Okay, so we are on lesson 4. So you should have your notes, absolute value functions and absolute value functions and tables of values. So this is the sheet that we want you to have out right now. All right, and what you're going to see is, once again with our standards-based grading, all right, that you're going to see very similar types of standards, but one is going to be for linear, one's going to be for absolute value, one's going to be for quadratics, one's going to be for exponential. So very similar things that we're going to ask from you today, that we've asked from you for the last couple of days in regards to table value. So I want you to be able to identify an absolute value function from a table. I want you to be able to identify its rate of change from a table. And then once again, use that pattern from rates of change to extend the table, fill in those missing values, all that good stuff. So to get us going, let's look at a situation here. All right, so due to a drought, all right, the canal from a reservoir is open so that the reservoir is lowered by 15 feet for 6 days to meet the irrigation needs of farmers. All right, and I should say 15 feet per day for 6 days. All right, so 15 feet per day for 6 days. After this, the canal is closed and water is directed from a river to raise the water level back to its original level at the same 15 feet change per day. All right, so here's what we want you to do. All right, we're going to look at this problem in two different ways, right? So one is we really want you to have a visual image of lots of situations, because if you can picture it, if you could sketch it, if you can draw it, that's going to help you with a lot of the algebra and the math that we're going to do with that particular situation. So right now, pause the video, take 15, 30 seconds, and sketch a graph. What do you think this is going to look like, all right, for this particular situation? And think back, all right, to some of the things that we've talked about way back in lesson 1 when we were doing those graphs and those matching those situations, and think back to kind of the pictures that you saw for those guys. So talked a little too much. Go ahead and pause the video. Draw me your sketch. All right, so let's see how you did. Okay, so now when I look at this, all right, we know that it is lowered for 15 feet, all right, per day for 6 days. That's a constant rate of change. It's going to go down by 15, go down by 15, go down by 15, go down by 15, go down by 15 over those 6 days. Now, what happens? Right now, they're going to raise it back up, and it's going to go back up at that same rate of change, right? So now it's going to go up by 15, up by 15, up by 15, up by 15. And notice, all right, it's linear down and then linear up, and it creates a V. All right. So there's where it's going to be very similar to a linear function, is that it's going to look like a line in the beginning and the end, but it's going to change direction. All right, a linear function does not change direction. All right, it goes down, all right, and it keeps going down. All right, or it goes up and keeps going up. It does not have that change of direction, which we call a turning point or a vertex. All right, so now another way we could look at this is through a table of value. All right, so here's what I would like you to do, all right, is go ahead and see if now you could take this same information, all right, from the problem and create a table of values, all right, to see what that would look like. All right, so once again, go ahead and pause the video, give this a shot, see if you can put some information in here and see what happens. All right, so let's check out your work. So now when we look at this, right, so if we, and I went ahead and extended all the way out to 12. You didn't have to. You could have just filled in what, I think your table only goes up to 10. But we can see, right, that if we're counting days, we are just all going up by 1, right? So up by 1, up by 1, up by 1, all the way to 12 days. Now, once again, we know that the original, right, the initial level, so initial, we've talked about that, right? That initial point, that initial condition, right? That's usually when x is 0, was 500 feet. And then what we saw was that it went down by 15 feet the first day, and then went down by 15 feet the next day, and then down by 15 feet, and then down by 15 feet, and then down by 15 feet, and down by 15 feet once more. So you can see there's that constant rate of change, right? Negative 15 to 1, 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 right? And it looks like it's in fact going to be linear. But now here's what happens. we get to that 6th day. This is now the lowest point of that reservoir, right? Now they start pumping water back in, and now it changes direction, right? So at this point, we now have that change direction, and that's our turning point, or vertex, right? And now notice, now we get 15, but in the opposite direction, because we now need to start filling the reservoir. So now it's going to go up by 15, up by 15, up by 15, up by 15, and then for 2 more days until we get to that, all right, original level of 500 feet. So you can see that the really, really big difference here between a linear function and an absolute value function is that turning point. All right, we're still going to see a constant rate of change, but we're going to see it in both directions. We're going to see a plus 15, a minus 15. We might see a minus 8, but we'd also have to see a plus 8. So those are some things to think about, all right, as we move forward. So now, if you look at the bottom of your page of notes here, we have our key characteristics of an absolute value function. Now, if you need to pause the video and write all these down, go ahead, or you can listen to me say this, all right, or describe these and then write them down, but you definitely need to write them down. All right, and notice that first characteristic of an absolute value function is what I was just talking about. We have a constant rate of change in both directions. So we have a positive version and a negative version. So sometimes it'll go up and then down, all right, sometimes it goes down and then up. All right, so it increases and decreases, or it decreases and increases. And this also, all right, and I'm going to just pop back into this, create symmetry. So notice around 6, 4, 10, right, that's our turning point. If I work up above that point and I look down below that point, notice that the Y values match, right? So 425, 425, 440, 440, 455, 455, 470, 470. So we see that symmetry, all right, within, all right, our table of values because of that constant rate of change, and it goes down and then up or vice versa. Now, the turning point, all right, so our vertex, we should be able to find that. And then what this means is that we get a V-shaped graph, right, and that V could be either way. So it could be a right side up V or an upside down V, but we're definitely going to get that V shape. All right, so now that we've summed all that up, once again, if you haven't written this down, pause the video, get this into your notes, right? So you want to be able to refer back to these things when you need to study, all right, for your assessments. All right, so now, let's flip over, and we're going to look at a few examples, all right, to get us thinking about, all right, taking these concepts and then putting them into the table situation that we've been looking at with linear functions prior. All right, so now, let's look at example 1 here. All right, so once again, it looks very similar, right? Okay, and we're going to really use a lot of the same ideas that we've talked about for the past 2 lessons, all right? But we have to recognize certain things to let us know that it's no longer linear. So, okay, so we're going to really utilize a lot of the same things that we've talked about, all right? But we have to look for those subtle changes between linear and absolute value. So let's look at those the changes of x on the left side. So my first change of x is a +1. My second change of x is a +1. My next change of x is the +1. All right, +1 again, +1 again, +1 again, +1 again. So we have a constant change of x. Everything is going up by 1. So now let's look at what's happening on the other side. Let's look at our changes in y. So notice my first change in y is -3. My next change in y is -3. So this makes it look linear, right? -3 to 1, -3 to 1, right? My next rate of change for y, or excuse me, change of y is -3. So once again, I get a -3 to 1. So right now, we think it's linear. It looks linear, all right, until this next step. Because notice what happens when I go from 12 to 15. I add 3. And so what has happened at 9:12? That is our turning point. Circle that dude, man. Highlight it. Do something. We always want you to mark that table of values, excuse me, that turning point in the table of values, because that really, really will help you see everything. So notice now, after we pass 9:12, everything's going up. And we want to see symmetry. So notice 15 is right above 12, 15 is right below 12. Now we want to continue this rate of change. So I added 3 there. So now I'm going to add 3 again. 15 plus 3 is 18. And we can see that that matches the 18 above. All right? And then I want to add 3 again. This should match what's above 18, which is 21. Now, notice this. We don't have a match here, but we just continue our pattern. We add 3, and we get to 24. All right, so that's really, really, really the big difference between linear and absolute value, is that turning point, right? So we have a constant rate of change, and then it's opposite. All right, so now how do we describe this rate of change? Well, we say it's a constant of plus or minus 3, all right, because we have both of those. We don't just have one, all right, or the other. We don't have just a positive or a negative. We have both, so we're going to write it with that plus or minus symbol. And then because of that, we know it's absolute value. Now, I abbreviate AV. You can write out absolute value if you want to. All right, so let's look at one more example here together. All right, now once again, if we start with, I'm going to flip to my example here. All right, if we start with that left-hand side, we can see that our x's, all right, and once again, you should be writing all these plus ones and plus whatever's out, minuses, all those little things on the side. Take great notes. All right, get into good habits now. We can see once again that all of the x's on our left side are increasing by 1. Right, so they're all going up by 1. So now, once again, let's look at where we have information. Let's start with 522. Let's look at our first rate of change, or excuse me, our first change of y to get our first rate of change. And when I go from 22 to 28, I go up 6. All right, but notice what immediately happens here. I go from 28 back down to 22. I changed direction. I went from adding 6 to subtracting 6. That's that turning point. That's the vertex, whichever term you want to say. All right, so now what I know is now there's going to be a pattern here, right? So I subtracted 6. When I go from 22 to 16, I subtract 6 again. When I go from 16 to 10, I subtract 6 again. All right, so now let's work that pattern backwards, right? So we know, all right, I had to add 6 to get to 22. Once again, let symmetry help you. I see 22, 16, 10. I should see 22, 16, 10 going back up, all right? And that is it right there. 16 plus 6 is 22. All right, once again, what did I add 6 to get to 16? There's that 10. There's that symmetry. And then one more time, all right, add 6. All right, so what did I add 6 to get 10? It would be 4. All right, so that is all for this lesson. All right, we will pick up. Oh, I guess I should finish the problem before I cut you off here. All right, I want to rob you if you're learning. No! All right, so once again, how do we describe that rate of change? It is a constant of plus and minus 6. And then because of that, with the turning point, we have an absolute value function. So now, that's the end of this lesson. All right, so what you should do now is you should log off. All right, you should see, go to Schoology. I didn't want to say Schoology, and I've been reprimanded for that. Schoology. You want to go to Schoology, and then do your Algebra 1, Unit 1, Lesson 4 video check-in. Let us know what you understand, what you don't, so that we can discuss those when we see you in class tomorrow. So have a great night. I'll see you next time. Bye.